Welcome and hi everyone, my name is Nurul Iman, binti Asma, Azmin, Rashid, and my metric number is 196316, and today I will explain about SL question 1, the solution. So my question is, show that if f is a vector field whose component functions have continuous partial derivatives on an operation that contains E, which is a simple solid region, and S is the boundary surface of E with positive orientation. This is the keyword. Then double integral bounded by S, f dot ds is equal to triple integral bounded by E, divergent f dot dv. So let's, I already sketched a simple diagram for the proving reference. So this is the diagram. This is not a cylinder, but it's just a region that connected by this line. So this is my surface 1, and then this is my surface 2. This is my E, domain E, and then this surface is my surface 3. So let's start, continue to the solution. So my solution is, let f is equal to pi plus qj plus rk, and let E be a simple xyz domain. This is my E just now, right? And then diverge f is equal to px plus qy plus rz. And then, as we know, for this f dot ds dot product, f dot ds is equal to fn dot ds, like this. So we can find this fn. So we just simply dot product f with n, we get p times I dot n plus q j dot n and plus r times k dot n, and then we substitute into the first equation, this first equation. So we get double integral by s p I dot n plus q j dot n plus r k dot n ds, and then we expand it and we can get these equations. We just simply expand the double integral, and then for the second equation, we just substitute our div f into this px plus qy plus rz, and we know that px, qy and rz is a partial derivative of del p over del x plus del q over del y, and so on. And then we just expand this equation just like this, and then we can get triple integral E del p over del x plus dot dv plus triple integral E del q over del y dv plus triple integral E del r over del z dv. And then to prove the divergence theorem, we need to show that this equation is equivalent. This p I dot n ds is equal to this del p over del x dv, and this q is equivalent to this del q, and this r is equivalent to this del r. So for this proving, I will prove type 1, which is double integral s r k dot n ds is equal to triple integral E del r over del z dv. This is dv, not dr. And then the type 2 and type 3 is just basically same the working for the solution to prove the equivalency. So our r, just let r equal to xyz, and our xy is in our, this is not d, have some typo, this is e, ey, f1. Our f1 is generated by s1, which is, this is s1, and then is the bottom part, and then this is s2. We give this is f1 xy, and then this one we give f2 xy. So the z is between f1 xy and f2 xy. So from this we get s, of course, s1 plus s2 plus s3, doesn't mind where the position of the s, and then r double integral s r k dot n is equal to double integral s2 plus double integral s1 and double integral s3. But in s3 it is the k dot n is perpendicular, thus it gives us 0. So for s3 we can cancel out because it just gives us 0. So then our s is equal to double integral s2 r k dot n ds plus s1 r k dot n ds. Okay, this is for our these are okay. And then we solve for s2 and s1. First we solve for s2. We just simply let t xy is equal to xi plus yj plus f2 xyk, because it's our s2 is used f2 xy, and for xy in e. And then we solve for the k dot n because we need to find this dot product. So this k dot n is equal to k dot tx times ty dA, because in the question it say that with positive orientation. So for S2 the positive orientation is given by tx times ty dA, this positive orientation. So this is a cross product, right? So if cross product we must do this k times I jk 1, we get this 1 0 because we differentiate respect to x, and the del f2 over del x, and then this differentiate respect to y, we get 0 1 del f2 over del y dA. And then we solve this part, we get negative del f2 over del xi minus del f2 over del yj plus k dA. But this is, we doesn't use this because we only want the k product. So it gives us k times k, 1k times 1k, we get 1 dA, and then we only get dA for this part. So for the S2 r x y z k dot n ds is equal to double integral e, right, just now, r x y, and our z is given by this part f2 xy dA. And then that's for S2. And then we solve for S1. We just use any variable, so I choose e xy is equal to xi plus yj plus f1 xy, because for S1 we use fy xy, so this must be equivalent for xy in e. So just now I said ds is equal to n dot ds, so we just find this our n dot ds, we get ey cross with ex, because for S1 we must find the positive orientation, and the positive orientation given by ey cross ex, not just like tx cross ty. So dA, and then we solve for the cross product in ijk. We differentiate respect to y first and then x dA, and then we get this. But here also we only want the k, so this is doesn't matter. If you don't need to know the del f1 and del f2 over del y. And then we substitute the equation. We got double integral s1 r x y z k dot n ds is equal to negative, because our k, this k is equal to negative double integral e, Rxy f1 f1xy dA. Thus we get for S we plus the S1 and S2. So we get this, the new equation. After we solve this we just plus this and this equation. So we get the integral E Rxy f2xy minus Rxy f1xy dA. And then from the previous question for this, we already solved for the double integral S, so we solve for triple integral E. So for triple integral E, I get triple integral R dr del R over del Z dV. Okay, from the second question, which is this triple integral E divergent F, we get triple integral E del R over del Z dV, and then we expand it, substitute the del R over del Z dZ dA, and then we get double integral E, and then we get Rxy f2xy minus Rxy fy xy dA. We just substitute this part. We solve for this first part, and then we get this equation, and thus this equation is same with this equation. So we already solved that double integral SR k dot n ds is equal to triple integral E del R over del Z dV. So the divergence theorem is proven. That's all from me. Thank you.
Hi, my name is Rahilla binti Ramle. My metric number is 196383. Today I'm going to explain about question 2. So the question is, use divergence theorem to calculate double integral f dot n ds. So for A, fxyz equals to cos z squared I plus yj plus cos x squared k. S is the cube, so the range is -1, xyz 1. So for B, the question is fxyz equals to x power of 2 yzi plus xy power of 2 zj plus xyz power of 2k. S is the box, so the range for x is 0 to A, the range for y is 0 to B, the range for z is 0 to C. So the solution for A is, first we need to find the div of fxyz. So we differentiate the equation. So we differentiate for I, we differentiate respect to x. So delta over delta x cos z squared plus delta over delta y plus delta over delta z cos x squared. So this one we differentiate respect to x, this one we differentiate respect to y, this one we differentiate respect to z. So we get 1. And then we find the divergence theorem. We triple integrate, as the range is the same for A. So we put the value here, and then we differentiate we integrate respect to dy, dx, dy, and dz. And then when we integrate respect to s, we get x, and then we substitute the value 1 and -1, and then we get 2, and then we integrate respect to y, we get 2y, and then we substitute the value into y, and then we get 4, and then we get 4. And then after we get 4, we integrate respect to z, we get 4z, and then we substitute the value into z, and then we get 8. So the answer for A is 8. So the solution for B is, first, as usual, we need to find the div of fxyz. So we differentiate the first one respect to x, the second one respect to y, and the third one respect to z. And then we get 2xy plus 2xyz plus 2xyz. So this one is the same. So we need to combine. So we get the final one, we get 2xy plus 4xyz. And then we need to find the divergence theorem. So we do the triple integrate. So for triple integrate and integrate respect to dx, dy, and dz. So this one is the range for x, this one for the range for y, and this one the range for z. So we integrate respect to x first, and then we get x power of 2y plus 2x power of 2yz, and then we substitute a and 0 into this equation, and then we after we substitute, we get a power of 2y plus 2a power of 2yz dy dz, and then we integrate respect to y. This equation we integrate respect to y, we get a power of 2 y power of 2 over 2 plus a power of 2 y power of 2z. So this one is, we does not substitute b the range of y yet. After this we substitute, and then this one is after we get the integration of dy, and then we substitute b and 0, and then we get a power of 2 b power of 2 over 2 plus a power of 2 b power of 2 z dz. And then we integrate respect to z, we get a power of 2 b power of 2 z over 2 plus a power of 2 b power of 2 z power of 2 over 2, and then we substitute c and 0 into this equation, and then we get the final answer is a power of 2, b power of 2, and c power of 2. So that's all from me. Thank you.
Assalamualaikum, my name is Mizan Qistina binti Juri. My matrix number is 1975444. The question that I get is question 3, which is calculate flux in each case, which is R equals to xi plus yg plus zk. So for question A, the question is vector function f is given as r over magnitude of r cubed. S is the solid sphere, which is x minus 2 square plus y square plus z square less than and equals to 1. So the answer is, first we have to assume, we have to let f equals to mi plus nj plus pk be a vector field, where m and p have continuous first order partial derivative on a solid S with boundary delta S as stated as in the question. Now, the Gauss theorem states that if n denotes the outer unit normal to delta S, then double integrate delta S f dot n ds is equals to triple integrate divergence of f dv in a region S. So we have divergent f is equals to divergent r over magnitude of r cubed. Then we just find the divergence by doing the differentiation, and the final answer we will get divergent f equals to 0. So since we get divergent f equals to 0, we will get the flux is equals to 0. Okay. For question B, the question is f equals to r over r magnitude r cubed. S is the solid sphere, x square plus y square plus z square less than and equals to a square. So the first part, we just take this one same as in question A, but this part we will take double integral fn ds in region delta S plus with double integral fn ds in region delta SA is equals to triple integral divergent f dv in region S. So we have divergent f equals to divergent r over magnitude r cubed. Okay, this is same as question A, which is we have to find the divergent f, and the final answer we will get 0. Since divergent f is equals to 0, so we will get this one. we will bring this into here. Okay, then we get minus. On surface delta SA, we have n equals to minus r over magnitude of r, and magnitude r we let magnitude r equals to a. Then we will get minus double integrate fn ds in region delta SA equals to minus double integral minus cm r over magnitude r cubed times with n minus r over magnitude of r ds in surface delta SA. So we will bring the minus cm to the front, and we multiply both r, and we will get r to r, and r cube times r, we will get r to the power of 4, and r to the power of 4 is equals to a to the power of 4. Same with a r square, we will get a square. Then we will get the answer minus cm over a square double integral 1 ds. So next, we know that double integral in ds in surface delta SA represents the surface area of the sphere with radius a. So double integral ds is equals to 4 pi a square. Then minus double integral delta SA fn ds is equals to minus 4 cm. Now we have minus cm as 1. Then the minus double integral fn ds is equals to minus 4 pi. So double integral fn ds in region in surface delta S is equals to 4 pi. So that is the final answer.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. My name is Mizan Kamalina binti Juri. My metric number is 198052. So today I want to discuss about question 4a, which is use the divergence theorem to find the outward flux of the vector field F equals to x cube I plus y cube j and z squared k across the surface of the region that is enclosed by the circular cylinder x square plus y square equals to 9 and the planes z equals to 0 and z equals to 2. So to find flux by using divergence theorem is we can use this formula: triple integral divergence of f dv in region D. So we have given f equals to x cube y cube z square. So to find divergence of f, we can use formula dp over d delta p over delta x plus delta q over delta y plus delta r over delta z. So we will get, from here we will get 3x square plus 3y square and 2z. So from the equation we know that x square plus y square equals to 9. So from here we will get r equals to 3. From here we will get r equals to 3. By using polar coordinate, x is equals to r cos theta, y is equals to r sin theta. By using Jacobian, we will get dx dy equals to r dr d theta. So now we go to this formula, right? So this is the region for x, y and z. Delta f, divergence of f we have got is 3x square plus y square plus 2z dz dy dx. So from here, this is region D. We can substitute the range for each x, y and z. So For x, we know that it is polar coordinate, so the range is 0 to 2 pi. Since it is a circular cylinder, so the range is 0 to 2 pi. For y, we have, for x we have theta equals to 0 to 2 pi. For y, we have r, which is the radius for the circular cylinder, which is 0 to 3, and given z is equals to 0 to 2. So this 3, x squared plus y squared is equals to r squared. So we substitute r squared plus 2z. Since we have dx dy is r dr d theta, substitute into this one, so we will get r dz dr d theta. Now simplify the equation. R equals to 0 to 3, z equals to 0 to 2. We will get 3r cubed plus 2rz dz dr d theta. Now integrate with respect to z, we will get integrate with respect to z, we will get 3zr cubed plus 2rz square over 2, 0 to 2 dr d theta. Now substitute 0 and 2, we will get 3 times 2 is 6r cubed plus 4rz dr d theta. So next step is to integrate with respect to dr. We will get 6r power of 4 over 4 plus 4r cubed over 3. Integrate from 0 to 3 d theta, then we will get 0 to 2 pi. Three over 2 times 3 power of 4 plus 4, 3 cube over 3 d theta. If we calculate, if we will get 279 over 2 d theta. Now integrate with respect to theta, we will get 279 over 2 theta from 0 to 2 pi. Now the answer is 279 pi. So that's all from me. Thank you.
Assalamualaikum. My name is Farah Hannani binti Haidzir. My matrix number is 196474. Today I'm going to present on question 4, part B. The question is, use divergent theorem to evaluate FDS, where F is given like that and S is the surface of the box with the limit of x, y and z given in the question. And also note that all 6 sides of the box are included in S. Okay, for this question, firstly we need to use divergent theorem. So what we have to do is we need to change this form into this form here, where we integrate the region D. Here the function is del dot f dv. Okay. Firstly, we got our del dot f here like this, because we know that del is del x, del y and del z, and our f is pqr. So in this question, we know that this is p, this is q, and this is r. So for to get del dot f, we need to differentiate first del p with respect to x, del p del x. So here our p is sin pi x. So if we integrate, if we differentiate, we will get pi cos pi x. So our q here with respect to y, so zy cube will become 3zy square, and also our r with respect to z, so z square plus 4s we will get 2z. Okay, so now we have our function here, which is del dot f. Del dot f, we get this function. Now we just need to integrate this function. So we need to find what is the limit for y, x, and z. And note here, dv equal to dy, dz, and dx. Okay, for this question, it is easy because it's already give our limit here for x, y, and z, which is z negative 1 to y 0, 1, and z 1, 4. If we sketch, also we get the same. We can see that the limit is as given in the question. So it is just a simple integration. First, I differentiate dy, dz, dx. So I integrate y first. So from pi cos pi x 3zy cube plus 2z, so we get here. So this is, if we integrate, we just add y. Here y become y cube over 3, so we left with zy cube plus here 2yz. So we substitute the value of y 0 from 1, so we will get equation here. Now we need to integrate with respect to dz. Okay, so this question we will just add z here, so become pi z cos pi x plus here is z square over 2, and here is z square. So we substitute the value of z, and we will get this function here, and then we simplify the equation. So we will get 3 pi cos pi x plus 45 over 2 dx. Now we left with integrate for the x. So here we will just integrate cos with, we get negative sign 3 pi, and we differentiate the inner function, we will get pi here, we cancel pi, and here we will get 45 over 2x. Now we substitute the value of x, which is 2 and 1. So we get the answer here is 135 over 2. So that's all from me. Thank you. In this video, I'm going to present on question 4c. It is the same question with different function. In this question, we need to use divergence theorem like previous question to evaluate f ds, where f is given in this form and S is a surface of the solid bounded by this equation, z equation here, which is z equal to 6 minus 2x squared minus 2y squared, and the plane z equal to 0. Okay, we need to note that both of the surface of the solid included in S. Okay, first thing, we need to use divergence theorem. So we need to change these forms into this form, which is we need to integrate region D, and the function here is del dot f dv. As I mentioned in my previous video, that del is del x, del y, del z. If we dot product it with f, we will get here del p del z, del p del x. So here our p is given in the f function, which is 2xy. So if we differentiate it with respect to y x, we will get 2z. And here our q, with respect to y, we will get negative y xy. And here our z, our r, we differentiate with respect to z, we will get 2 minus 2z. Okay, next we simplify the equation, we will get 2 minus y xy. Okay, now what we need to do is integrate 2 minus 8xy dz dy dx. Okay, firstly we need to sketch the pictures for us to easily find the limit and see what happens here. So now we get the circle with radius set 3 here. And first, to make the equation, to make the solution easier, we can change the z equation here given in the question in the form of r, because we need to use r when we integrate the circle. So here x square plus y square, we can return it as r square, because here x square y square, we know that x is r cos theta and y is r cos theta. So when we substitute that, we will get r square cos square theta plus r square sin square theta, and we put the r square outside, and then this will become 1 and we get r square. That's why our z is 6 minus 2r square. Okay, so here we continue. Dx and dy equal to r d theta. So our integration is not in the form of dx, dy, dz anymore. We need to change the dy and dx into the r dr d theta, but we keep the dz here. So for the limit for the z function, we can see that here z is from 0 into the equation here. The equation for z are given in the question. It is like this, but we already changed it into the r because we want to make it simple, because we doesn't have dx and dy here. We need to change it into r. So our z is from 0 to that equation, and then our r is from 0 to set 3, because our radius is set 3, and theta is 0 to 2 pi, because this is a complete circle. Okay, now we just input the question we get from the del.f here. So for x and y here, we substitute with r cos theta and r sin theta here. So we will get 2 minus 8 r square sin theta cos theta. This is from here, r here, r d theta, and dz here. Okay, so I factorize 4 here. So I insert 2 here because I want to make this equation become 2 sin theta cos theta. So I change it into 4 here, and we get 2r, because this is 2 multiple with r, and this is r cube become r, this is r square become r cube, and this form here I can change it into sin 2 theta. So we make our calculation become simpler. So from here I just integrate this equation with respect to z. So 2r, I get 2rz minus 4 zr cube sin 2 theta, and then I substitute the function here into z. So I will get this equation here, and I simplify the equation. Also then I multiply this equation here with sin 2 theta here, and then next I integrate this equation here with respect to r. So I get 6r square minus r 4 minus 6r4 sin 2 theta plus 4 over 3r6 sin 2 theta. So I need to substitute the value of r here, set 3 and 0. So when I substitute the value of r, I will get the equation here. So now we only left with the d theta. So our theta, I simplify this equation. I get 9 minus 18 sin 2 theta, and then I integrate it with respect to theta. and I get this equation, and we need to substitute 2 pi and 0 into the theta. So I get 80 pi plus 9 minus 0 plus 9. So the final answer I get is 80 pi. Thank you.